Welcome to Two Projects. In this video, we are going to explain the project Detection and Classification of COVID-19 on CT Images. Before diving into the execution, let me give you an overview of the project. So, the project aims to develop an automated system for accurately detecting and classifying COVID-19 cases from CT images, crucial in the fight against the pandemic. Traditional methods like RT-PCR tests are time consuming, prompting the need for faster alternatives like CT imaging. But manual interpretation of CT scans is subjective, necessitating automated solutions. So, we will be using deep learning models for interpretation of CT scan images. So, the project starts with exploring a dataset of COVID-19 CT images and applies various image processing techniques for data preparation, and data augmentation is used to enhance model robustness. Multiple deep learning models, including YOLO V5, FASTA RCNN, and SSD, are implemented for training and evaluation alongside a user friendly Flask interface with SQLite for user interaction. So, during detection, users input CT images which undergo pre processing and are fed into the trained model. The system segments detected objects and provides a final outcome indicating COVID-19 presence. So, the project aims to enhance diagnosis efficiency, provide a user friendly interface, and facilitate timely patient management, benefiting healthcare professionals and individuals seeking COVID-19 screening. So, this is what happens in this project. Now, we'll look at the software and hardware requirements to execute this project. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language required is Python, front-end framework needed is Flask, backend framework required is Jupyter Notebook, database needed is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. So these are the algorithms built in this project YOLO V5, FASTA RCNN, and SSD. So we have trained them and compared the performance of these models using different performance metrics like MAP, precision, and recall. And we have observed that YOLO V5 has outperformed other models in all the performance metrics. So we have deployed YOLO V5 into the Flask web application. So we will be executing the project using Flask. Before execution, first we need to open the code folder which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. This is data folder in which I have required dataset of CT scan images. So I'm opening data folder. So in images folder, I have images along with the labels, that is annotation files. So here we can see I have train and valid sets. So the images and label files from the images folder are split into train and validation sets. So train set is for training the models and validation set is for evaluating the model's performance. So in train folder, I have images and label files. So these are the images, the CT scan images. And in labels folder, I have label files or annotation files. So each label file or annotation file corresponds to an image file in the images folder. This annotation file corresponds to this image. Similarly, this annotation file corresponds to this image. In the same way, each annotation file corresponds to an image file in the images folder. So these label files often follow the YOLO format, where each line, so this is the line, represents a detected object. So the first column indicates the object's class index and followed by the bounding box coordinates. normalized to the image dimensions. So these are the bounding box coordinates. This is x limit, this is y limit, this is the width, and this is the height. So this line represents a detected object in the image. So in this image, there is one object detected. Similarly, I have objects class index followed by its bounding box coordinates in other label files also. So each line in these files represents a detected object, and each annotation file corresponds to an image file in the images folder. So we will be training the deep learning models on these images and labels. So I have images and labels in valid folder also. On these images and label files, we'll be evaluating the model's performance. So this is about the data set. So in images, I have two classes of CT scan images. One is diagnosed with COVID-19 and the other one is not diagnosed with COVID-19. And this is sample folder in which I have images again of CT scan images. So on these images, we will be making the detections. That means these are the test cases we have. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And these are all model files which contain algorithm information. So these files contain algorithm information which will be loaded into the project during execution. This is Notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. So it stores information like user signup details. So this is about the code folder. Now copy the path of the code folder from the address bar of the file explorer. This is the path. I'm copying it. Open Anaconda prompt. So use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and performs a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. So this is the localhost and this is the port. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I usually prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. If we are new users, we have to register ourselves first, fill in all these details and click on register button to sign up. And if we already have account, we can directly log in by clicking on this link. So as I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine and click on login button. So it has redirected us to the detections page. So now we have to upload any CT scan image of lungs here and the application will detect and classify the presence of COVID-19 from the image. Click on choose file button. From sample images folder, these are the test cases I have. Select any image. I'm selecting this one and click on open. The image has been loaded. Now click on upload button. So the system looks for specific features or patterns indicative of COVID-19 infection from the CT scan image. So we can see it has drawn a bounding box around the detected abnormality. It has classified the abnormality as COVID-19. We can see the bounding box here and we can see the label, that is COVID. Beside the label, we can see a confidence score telling us the confidence level of the application in classifying it as COVID. Click on back, click on choose file. We'll try with this image. Select the image, click on open. The image has been loaded. Now click on upload button. So we can see the application has detected the COVID. We can see the bounding box drawn. We can see the label. And beside the label, we can see the confidence level of the application and classifying it as COVID. Click on back. Click on choose file. We'll try with this one. The application has not made the detections. We'll try with another image. We'll try with this one. We can see the application has detected the abnormality. It has drawn a bounding box around the detected COVID. We can see the label. Beside the label, we can see the confidence score. Click on choose file. This time we'll try with this image. Select the image, click on open. The image has been loaded. Now click on upload button. So we can see the application has not detected any abnormality. So it has drawn a bounding box around the CT scan and it has classified it as non-COVID. And beside the label, we can see the confidence score telling us the confidence level of the system in classifying it as non-COVID. Click on back, click on choose file. We'll try with some more test cases. We'll try with this one. Select the image, click on open, click on upload. So we can see the application has classified it as non-COVID. We can see the bounding box drawn around the CT scan. So there are no abnormalities found. So it has classified it as non-COVID. And we can see the confidence score. We'll try with this one. We can see the COVID detected. We can see non-COVID detected. So there are no abnormalities found. So it has classified it as non-COVID. We can see the bounding box drawn and we can see the confidence score here. So in the same way, we can upload any image from the test cases and can get the detections and classifications of the presence and absence of COVID-19 infection. We can see the COVID detected. We can see the bounding box drawn around the detected abnormality. We can see the label here, that is COVID, and beside the label, we can see the confidence score telling us the confidence level, how confident the application is in detecting it as, in classifying it as COVID. Click on back. So now we'll look at the graphs. Click on about link. Here we can view all the visualizations made. So this is F1 confidence curve graph. This is precision recall curve graph. This is confusion matrix graph. This is precision scores comparison graph, a horizontal bar graph. In this graph on x-axis, I have precision scores and on y-axis, I have algorithm names. So precision is a measure of the correctness of positive predictions made by a classifier. This is recall scores comparison graph. In this graph, on x-axis I have recall scores and on y-axis I have algorithm names. These are the algorithms built. So recall is a measure of the classifier's ability to correctly identify all relevant instances from a data set. So from these two graphs, we can see YOLO V5 has outperformed all other models. And here we can see the detection made from the Jupyter Notebook. So these are the visualizations. Now click on sign out. So we developed an automated system for detecting and classifying COVID-19 cases from lung CT images. Through image processing and deep learning, it provides a rapid and accurate tool for aiding healthcare professionals in diagnosing COVID-19 infections.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.